Welcome to EPIT Research Labs Private Limited. Today, we introduce a new product, an IoT-based solar EV charging system and battery monitoring system using the internet. We utilize a wireless electric vehicle equipped with the SP32 and Arduino. The transmitter sends power from the solar charging circuitry using a 12-volt BMS system, based on an IR sensor. The charging station activates only when a vehicle is present, otherwise, it remains inactive. The system includes a 12-volt, 3-watt solar panel for power transmission. The transmitter coils are placed on the road, while the vehicle is equipped with a receiver coil and an IR sensor underneath to detect vehicle presence. On the transmitting side, we monitor the voltage of the solar panel, which charges the battery through the solar charging circuit and 12-volt BMS circuitry. On the receiving side, the vehicle is equipped with the SP32, Arduino Nano, and a BMS system for IoT connectivity and sensor data reading. Voltage sensors monitor individual cell voltages, along with a current sensor. Motors activate when a vehicle moves forward. The system's operation can be observed through an application, displaying voltage, battery health, current, load current, and battery percentage. For setup, the mobile hotspot must be enabled, followed by a device reset and activation of the SP32. These are the relays for protecting the device from the over-voltage and under-voltage charging conditions. Power transmission is initiated when the vehicle aligns with the transmitter coils, activating the coil's power via the air sensor. Wireless power transfer occurs as the vehicle moves along the coils. This concludes the presentation of our IoT-based solar EV charging system. Thank you.